So the MCQs is the transfer function for tachometer ES by theta S is KS K by S KS square. So let's discuss this, that what is mean by tachometer. So tachometer is an instrument which measure the rotation, which measure the rotation, or you can say that which measure the revolution per minute, RPM, which is the revolution per minute of engine. So tachometer is an instrument which measure the rotation, yeah, revolution per minute of the engine. Okay, and this is tachometer is widely used in automobile. It is widely used in airplanes, etc. Okay, so tachometer is such type of transducer which is used as a feedback element in control system. So in control system, we use this as a feedback element. In control system application, we use this as a feedback element. So this is actually a small DC generator. Tachometer is basically a small DC generator in which we give mechanical speed. Input is the mechanical speed, and it give you an electrical voltage. So the input is the mechanical speed and the output is the electrical voltage. And this electrical voltage is directly proportional to speed, speed of the input. Okay, mechanical speed, speed of the input, and that is the rotational speed. So this will be omega, and omega is equal to d theta divided by dt. So, and let's say electrical voltage is represented by E. So this E will be directly proportional to rotational speed. So E will be equal to K. K is the constant of proportionality, omega, and that will be equal to K d theta divided by dt. And let's convert it into a S domain. So it will be E into S will be equal to K S into theta S. So your ES divided by theta S will be equal to Ks, or your ES divided by omega S will be equal to K. So the question is ES divided by theta S is, so ES divided by theta S is Ks. So option B is the correct answer. Okay, next MCQs is transient state analysis deal with magnitude of error, nature of the response, both 1 and 2, none of these. So let's discuss it in detail. So transient state analysis deal with the nature of the response of the system, that your system will give which type of response. So that is deal by the transient state analysis. Steady state analysis give you the steady state analysis deal with the estimation of the magnitude of steady state error. So transient state analysis deal with the nature of the response of the system, while the steady state analysis deal with the estimation of the magnitude of the steady state error. Okay, so transient state deal with magnitude of error. Now that is the steady state analysis. Nature of the response. So yes, option B is the correct answer. That is the nature of the response. Okay, next MCQs is Open loop transfer function GS is S minus 2 divided S plus 2 is a all pass filter, band reject filter, non pass filter. So actually your transfer function numerator is 0 and denominator is poles. So 0 is at S is equal to 2 position and pole is at S is equal to minus 2 position. So this is on the left hand side and this is on the right hand side. So if this is your graph, so this is your right hand side, this is your left hand side. So here pole is at minus 2 and 0 is at plus 2 position. So these two poles denote the symmetrical mirror image. Symmetrical mirror image. So the given open loop transfer function denote all pass filter because it gives you symmetrical mirror image. Okay, next MCQs is when compared to a first order low pass filter, a second order low pass filter has lower voltage gain? No. Higher voltage gain? No. Higher cutoff frequency? Yes. This is the correct option. Higher cutoff frequency. Faster drop in filter response? No. So actually, the what is mean by first order low pass filter and second order low pass filter? So actually, the first order low pass filter have either one capacitor or one inductor, while the second order filter have two capacitor or two inductor or one capacitor and one inductor. Actually, the number of order is determined by the number of active components. Okay, number of order is determined by the number of active components. That and these components affect the filter frequency response. Filter frequency response that is affected by these active components, and we find the order of the system from these active components. Okay, so the low pass filter will be like this. Let's say this is my y-axis, this is my x-axis, and here I have 0 dB, here I have minus 3 dB. So the curve will be start from 0 dB and will come over here, then it will gradually drop. So this minus 3 dB, so this point, this is your corner frequency, which is represented by F.Sc. This is your corner frequency, and this is your band pass, and this region, this start from this up to this represent the band stop region. Okay, so the bandwidth of this frequency, this is the bandwidth of this. So this is the bandwidth. Okay, start from this up to this, and as it passed the lower frequency, so that's why this is known as low pass filter, and it filter out the high frequency and it passed the low frequency, so that's why it is known as low pass filter. And this on y-axis we have gain, and the formula for this gain is equal to, in case of voltage, that is equal to 20 log V out by V in. Okay, next MCQs is the step response of the system described by the differential equation will be, so this option is given to me. So as we know that the transform function is your output divided by input. So input is the step response. So that will be, if I convert the step response in S domain, so that will be 1 divided by S. And transfer function is given to me. So that is this one. So let's convert this into an S domain. So this will be like, as we know that S is equal to D divided by dx. So that will be S into capital YS plus 6 into capital YS, and that's equal to capital XS. So this will be your YS will be, so that will be S plus 6 is equal to XS. So your y s divided by x s is equal to 1 divided by s plus 6. So output divided by input, that is equal to the transform function. So transfer function is 1 divided by s plus 6. So put the transfer function in this star equation. So we will get, instead of transfer, I will get 1 divided by s plus 6, that is equal to output divided by input is 1 divided by s. So if I bring 1 by s over the left side, so it will become 1 divided by s into s plus 6, that's equal to output. So if I convert it into a time domain, so it will be 1 divided by s into s plus 6, that's equal to a divided by s by partial fraction plus b divided by s plus 6. So if you solve this equation, then you will get a is equal to 1 divided by 6, and b is equal to minus 1 divided by 6. So this will be equal to 1 divided by s into s plus 6 will be equal to 1 divided by 6s plus, sorry, minus 1 divided by 6 into s plus 6. So let's 1 divided by 6, take 1 divided by 6 as a common. So 1 divided by 6 is common, so I will get 1 divided by s minus 1 divided by s plus 6. So 1 divided by 6 will be equal to e to power 0t minus e to power minus 6t. So that will be equal to 1 divided by 6 into 1 minus e to power minus 6t. So is there any option that's equal to 1 divided by 6, 1 minus e to power 6t? So yes. So option A is the correct answer. Okay, next MCQs is the impulse response of the system described by the differential equation will be 3y by x is equal to xt. So this option is given to me. So the impulse response, so my transfer function is equal to ys divided by xs. So input is 1, that is the impulse response. And let's now use this equation. So this will be 3s ys in s domain, this will be 3s yx, that's equal to capital X into S. So your ys divided by xs will be equal to 1 divided by 3s. So that is equal to the transform function. So 1 divided by 3s is equal to ys divided by xs, that is equal to 1. So your ys will be equal to 1 divided by 3s. So your ys will be equal to 1 divided by 3 e to power 0t, that's equal to 1 divided by 3. So option C is the correct answer. Okay, next MCQs is the impulse response of the system described by the differential equation dy by dx plus 6y is equal to xt will be, so this option is given to me. So impulse response, so my xt will be equal to 1. And let's find yt. So the transfer function that will be equal to, let's convert this into an S domain. So this will be S into ys plus 6 into ys, that is equal to xs. So ys will be equal to s plus 6 is equal to x s. So your ys divided by x s will be equal to 1 divided by s plus 6. So x s is 1. So your ys will be equal to 1 divided by s plus 6. So in t domain, this will be equal to e to the power minus 6t. So e to the power minus 6t is the correct answer. Okay, next MCQs is the type of a control system is obtained from dash transfer function, open loop, closed loop, both open and closed loop, none of these. So actually the type of the system is obtained from the open loop transfer function. And the number of open loop poles occurring at origin. Origin means s at s is equal to 0. Occurring at origin give us the type of the control system. If the number of open loop poles is 2, then the type of system, then that is the type 2 system. If the open loop pole is 1, that is the type 1 system. If the number of pole is 0 at the origin, then that is the type 0 system. Okay, next MCQs is what is the type of closed loop system for the plant transfer function? Gs is equal to k by s square 1 plus ts and with unity feedback. So for every transfer function, we have certain types and we have certain orders. So the steady state analysis depend on the type. Analysis depend on the type of the control system, and the type of the control system is obtained from the open loop transfer function. Open loop transfer function. The number of open loop poles occurring at the origin determine the type of the control system. So here if you see that the transfer function, open loop transfer function is k divided by s square and 1 plus ts. So we have two open loop pole at the origin. So this transfer function will be type 2. So option C is the correct answer. Okay, next MCQs is which of the following statement is true statement? Type of the system is obtained from open loop transfer function. So yes, I discussed about this in last MCQs. The steady state analysis depend on the type of the system. Yes. Transient state analysis depend on the order of the system. Yes. So option D is the correct option. All of the above. So as I already discussed that the transient state analysis depend on order. Transient state analysis depend on order of the control system, and the order of the control system is obtained from the closed loop transfer function. And the highest power of the characteristic equation determine the order of the control system. The steady state analysis depend on the type of the control system. The type of the system is obtained from the open loop transfer function, And the number of open loop poles occurring at origin determine the type of the control system. We find the order from the characteristic equation of the closed loop transfer function, and we find the type from the number of poles occurring at the origin. So this is all about the today tutorial. See you tomorrow. Thanks for watching. Allah Hafiz.